This chapter is all about force and stress. Stress is different than what you're probably starting to feel as your homework piles up. Now, a couple of very important things. The terms force, stress, and strain are frequently used interchangeably in common conversation. However, in geology, that is wrong. They are not the equivalent to each other. The two that get mixed up probably the most are stress and strain. The best way I find of remembering the difference is that force on something is stress. So the force is the amount of effort or energy, so to speak, being exerted. The stress is that force on something. So there's, pounds is force. Pounds per square inch is stress. And then stress causes strain. You have a balloon, you have a 1 pound weight. That 1 pound is force. You set that on the balloon, it's exerting some pressure, some PSI, some stress. The balloon squishes. That is strain. Strain is the distortion caused by stress. Now, of course, being science and being geology, we're going to use SI units, so not pounds per square inch. We're going to be using kilograms, meters, and seconds. Now, force is a Newton, a kilogram meter per second squared in SI units. Stress is a Newton per square meter, a force per area. When you convert that into SI units, you end up with a kilogram per meter second squared. It's okay to write Newton per meter squared as long as you know that SI conversion, because sometimes you'll need to break it down into the kilograms and meters and seconds to be able to complete your equation. So these two conversions are very important. You probably want to make note of them. You also want to look at table 3.1, page 42 of your textbook, just to get yourself more familiar with the terms. So when you're reading, you'll have already seen that term and know what it is. Now we get to talk about Newton's laws. Hopefully you've seen this in physics class, but it's a good review. The first law, the law of inertia. In the absence of a force, a body that is moving will keep moving at a constant velocity, which includes, if it's at rest, velocity 0, it'll remain at rest, velocity 0. So the first law is the law of inertia. And again, Newton's 3 laws are important. They actually do show up on tests and homework and stuff like that. The second law, Newton's second law, is that force equals mass times acceleration. So when you have a body, whether it's moving or at rest, if you exert a force on it, then the result will be the acceleration times whatever the mass of that object is. We'll get to the third law later. Now, any natural process can be described using 4 basic forces. The things that are involved are gravity, electromagnetic forces, and then strong and weak forces. Strong forces are the nuclear forces. They're what holds something together, or in the case of fission, they're what are being broken and blasting something apart. And then weak forces are radioactivity. These frequently cause heat as things break down. A grand unified theory, a way to take these four forces and find some single root force that explains all of it, is a wonderful goal. So far, nobody can do it. Not even Einstein. Nobody's been able to unify all the forces. Gravity is the particular problem. Gravity doesn't mesh with the others into a single explanation. Now, body forces react from an action of a field at every point within the body. So it's like gravity acting on your body. Gravity is pulling your hand down, and your arm, and your torso, and your leg, and your head. Every point in your body, every molecule in your body is being pulled by gravity. So it's a body force, because it's acting on your whole body. A surface force is more like the wind, or if you have a Band-Aid and you're ripping it off of your skin. It's only affecting that surface that it's touching. It's not affecting your insides. It's not affecting other parts of your surface. You pull that Band-Aid off your arm, only your arm feels the effect. So that's a surface force. Now, moving from force to stress. This is a kind of stress that we're probably most familiar with. Too much going on, noise, caffeine, homework, and other stuff piling up. But geologically speaking, stress is different. We have a special symbol that we use to represent stress. It's called sigma. It's the little circle with a tail at the top. And we're going to see sigma a lot all semester. So that's definitely something you want to make sure sticks in your head. So stress, which is force per unit area. So sigma equals force divided by area. And stress is the intensity of the force. So if you have, 1 Newton of force and it's all concentrated in the tip of a needle, that'll puncture your skin, no problem, and it'll hurt. If you have 1 Newton of force and it's spread out over a large area, like a whole sheet of cloth, and you put that on you, it's comfortable. It's a blanket. We use that to get comfortable and fall asleep. So that stress, even though if the force is the same, how much area it's spread over makes a big difference. So stress is the intensity of the force. And the units are kilogram per meter second squared, or a Newton per meter squared, not a neuter, a Newton. And a Pascal is another term. It's 1 Pascal, 1 Newton per meter squared.